During the winter months, ice and snow can turn driveways and sidewalks into dangerous slip hazards. To combat the hours of manual labor necessary to clear ice and snow, some people choose to install a snowmelt system to keep their public access points safe during the worst winter weather. We begin by placing insulation into the gravel bed where the driveway will be poured. This insulation not only ensures that we direct the heat up to the surface, but can also make installation much easier. We also place insulation vertically on the sides to prevent heat from escaping horizontally. Remember, heat does not rise like hot air. Heat is attracted to cold, so insulating the zone properly is a critical step that many people overlook. This results in much more heat being needed to do the job, increasing energy consumption. The tubing is then placed per design on top of the insulation and locked in place. Snowmelt loops are generally placed 6 to 9 inches on center as opposed to 12 inches on center in radiant floor heating systems. The layout of these loops is critical to the overall operation of the system, so be sure to follow the provided layout carefully to reduce potential problems. Once the concrete is poured, it's too late to make changes. A snow sensor, also known as a puck, is installed between the tubes away from the road where salt and brine could damage the device. This sensor will tell the system when snow is present. The tubing is then routed to a zone manifold. The puck is wired back to a snowmelt controller. Once a successful pressure test of the tubing is completed to prove there are no leaks, the concrete can be poured, completely covering the tubing under the surface of the driveway. Then we add a boiler and piping system to distribute the heat to the loops as needed. Once it begins snowing, the puck sends a signal to the snowmelt controller, which sends a signal to the zone pump to flow water through the subsurface loops connected to the manifold. The manifold allows us to connect multiple loops of the same temperature to a single zone. A three-way mixing valve is recommended on systems where the tubing is under concrete to prevent temperatures over 120 degrees Fahrenheit from entering the loops. High temperatures may cause expansion cracks in the concrete and should be avoided. Remember, if a boiler can achieve temperatures of 185 degrees Fahrenheit, we have to assume it will, so we need to protect the low temperature loops. Water flows through the three-way valve until more heat is needed, and flow from the boiler is allowed into the zone manifold to increase the loop temperature. If the loop needs more heat at this point, the boiler will fire and activate the boiler pump to add heat to the loops as necessary. One of the many benefits to a snowmelt system is that we can melt snow at relatively low temperatures. Since we're using low temperature to heat the zone that is in direct contact to the outside environment, it is recommended to use a glycol mixture to act as an antifreeze for the system fluid. Water expands up to 8% when frozen, which can also crack the driveway or create leaks. Never use more than a 50% glycol to 50% water mixture. A 30% mixture is sufficient in most cases. And a glycol feeder is also recommended for the system to make adding glycol easy. Interested in learning more? Famous Supply's Hydronics team has over 400 years of combined knowledge to help you succeed, and we'd love to hear from you. Thank you for watching.